Welcome to Super Easy Physics and Mathematics. CPAM. This the episode 1 of the topical reviews of past IGCSE physics questions related to electricity. This episode deals with step-by-step explanation of how to calculate the value of combined resistance in a circuit, and electromotive force of a battery.
Question 7a. Define electromotive force. The electromotive force of a battery is the energy supplied by the battery to push or drive a unit charge around the circuit. So to move 1 coulomb of charge around this circuit, the work done, that is the electromotive force of the battery. Or secondly, you can say in terms of energy, is the number of joules of chemical energy transferred to electrical energy and heat when 1 coulomb of charge passes through the battery or cell. So that is the electromotive force. 7b. Figure 7.1 shows a circuit. The 2 lamps shown are identical. So you have lamp 1, lamp 2. Each lamp has a potential difference of 3 volts across it and a current of 2 ampere in it. So current of 2 ampere will flow through this lamp 1. The current of 2 amperes will flow through lamp 2. And the PD across the 2 lamps is 3 volts. What you should remember about this question is that when resistors are connected in parallel, the PD across resistors in parallel is equal. So the PD across lamp 2 is 3 volts, the PD across lamp 1 is 3 volts. PQ is a length of uniform metal wire. PQ is a length of uniform metal wire. The resistance of PQ is R. So the resistance is R. So I'm going to call it, I've used green for this particular, the resistance of this wire. So let's carry out a quick analysis. So let's try to find out the current flowing in each of these lamp. So the current that is going to flow in this lamp is the total current that will come that pass through the wire, which is the green. Then on getting here, the current will divide. Part of it, half of it will, since the current flowing through them, the 2 lamps, since the lamps are identical, their resistance are equal. So this lamp 1 and lamp 2 is going to divide the incoming current into 2 equal parts. So since the incoming current, so we have the current that flowed through the first one is 2 ampere, then the one that flowed through the second one is 2 ampere. So the incoming current is going to be 4 ampere. Then the resistance through each of them is going to be the PD across each lamp divided by the current flowing. So that each of the lamp have the resistance of 1.5 ohms. So with that, so you have 1.5 ohm, 1.5 ohm. So we can now find what is the PD across the wire. The PD across the wire, so the PD across the lamp, the parallel lamp, is 3 volts. If you add it to the potential difference across the length of the wire, PQ, that is resistance R, will give you the total EMF of the battery. So 12 volt is equal to 3 volt plus VR. So VR is the potential difference across the wire. So that gives you that the PD across the wire is 9 volts. So let's go and answer any other question that will ask us. The 2 lamps shown are identical. Each lamp has a potential difference of 3 volts across it and a current of 2 ampere in it. PQ is a length of a metal wire. The resistance of PQ is R. So we've already analyzed it. Question 1. Calculate the value of R. So the value of R. So for us to get that, since we know the PD across, this is 9 volts, which I have already explained. So this is 9 volts. So if you know 9 volts, you know the current flowing here is 4 ampere, which is 2 plus 2 to give you 4 ampere. So to calculate the resistance, so okay, we already know that. So it's going to be the PD across the wire divided by the current flowing in the wire. That gives the resistance of 2.25 ohms. So R is equal to 2.25 ohm. Another wire is made of the same metal as PQ. The length of the new wire is twice the length of PQ, and the diameter of the new wire is twice the diameter of PQ. So we have this one. So let's assume the yellow one was the original length, and then this blue one I'm just using it to represent a wire that is twice the length of the yellow one, and then the diameter is also twice this. So if the diameter of this is 1 cm, the diameter of the blue one will be 2 cm. So let's go. The resistance of a wire, this is a formula, is equal to the product of the resistivity multiplied by the length divided by the cross-sectional area. So the cross-sectional area, write it in terms of, since it's circular, write it, the area of a circle is equal to pi d square over 4. And then that value is equal to 2.4. So this is the original value. So let's substitute this value twice the length. So the new wire, the new resistance, the new wire is going to be 2L, twice the length. And then the diameter is twice the diameter. So that would be, if we expound this, that will give us 4 pi, because 2 times 2, 4 pi d square over this. So these two can cancel these two. That will give real L over 2 pi d square over this. So if you compare this value with this value here, you see the difference is this half under. So if I divide this by half, if I divide the original length by half, that will give me the resistance of the new length of wire. So you see that as the length increase and the diameter increase, the resistance reduced by half. So the resistance reduced by half, that will be 2.25 ohm divided by 2 to give 1.125 ohm. So put it in two significant figure, will become 1.1 ohm. So that is the answer to this question. With that, we are finished answering this question. So next, we are going to look at another aspect in episode 4. We're going to look at another aspect of electricity. So let's make our progress.
You are a brilliant student who wants to succeed. Please subscribe so that you keep up to date, because more tutorials solving past exam questions to assist you will be uploaded.